يعني wind depends on a lot of things, but above 750 ppm, it will be a killer. It will be a silent killer. That's why it's very important when you deal with a sour gas or a sour gas plant. It will be a very tough safety regulations and safety equipment must be used. Okay. This also, as we mentioned, it causes it's very corrosive to the pipeline. This is a corroded pipeline by the H2S. Okay, let's check. What is the abbreviation for BPM? BPM is part per million. Part per million. It's one part per million part. One part per million one. The 1% is one per 10,000 BPM. Okay, so the 1 ppm is 1 per million, 1 per million, 1 divided to million, okay, which is very, very small.
Uống một viên thực phẩm bảo vệ sức khỏe Fatmaton Energy mỗi ngày, hỗ trợ tăng cường sức khỏe, sức đề kháng, hỗ trợ tỉnh táo, gia hạn sẵn sàng trong mọi khoảnh khắc. Thực phẩm bảo.
Okay, the other contaminants are the non-combustible inert gases, such like the CO2 and the nitrogen. Why we need to remove them? Because they have no value. They reduce the heating value of the gas, and also they take valuable space in the pipeline. Sometimes the CO2 when get mixed with water becomes very corrosive to the pipeline and equipment. Okay. Let's take an overview about the gas plant in brief. The gas plant, we have fluid pipelines such as gas pipelines comes from different wells or gathering gas from some wells are collected to a gas header. And the header is a bigger pipeline which collects the gas from different pipelines. Okay. After that, the first thing in the plant is the slug filter. Slug filter is a separation process we will talk about in brief, at which the gas is separated from liquid. After that, the gas is, if the gas is sour, it went through sweetening or acid gas removal, sweetening process. After that, the treated gas from sweetening is entering the dehydration process or water removal process. After dehydration, the gas is called a sales gas, and it went to the metering station, at which we count the gas being sold. Okay. From the sweetening process, we have a byproduct, which is H2S extracted from the gas. H2S is sent to an SRU unit, which is sulfur recovery unit, at which we can recover the sulfur from H2S, and it can be sold in the market also. The liquid portion here is sent to a further separation, because when we are talking about liquid is almost condensate and water and MEG. We will talk about MEG in brief in a moment. Okay, so the liquids are going to separation. Mainly the condensate is sent to stabilization, and to the metering to be sold as stabilized condensate. The water is sent to important units are SWS and MRU. SWS is sour water saving, and MRU is MEG recovery unit, at which we recover the MEG. And the SWS is produce a waste water without H2S, which is sent to maybe be reused in the plant or sent to dispose. Okay. First unit in the plant is the slug filter. What is the importance of the slug filter? Slug filter is acting like a slug control. Sometimes due to chop up and chop down with the well, we receive slugs of water or slugs of liquid, which we cannot handle with the normal separation. So it's required to use some separator called slug catcher, which is a finger type like this, separator with finger type, can handle the high amount of liquid coming from the wells. And also, it is the first defense line when it comes to liquids and slug control. It is the first defense line. So when we expecting, when we are using, when we are separating gas from liquid, we have to use something like that. Especially when we expect different amount of liquids changing from time to another, and especially when the sea lines or the fluid pipelines are far from the plant. For example, in our plant, in Zohr gas plant, the wells are 200 kilometers far from the plant. 200 kilometers. So it's a very يعني long distance. So sometimes liquid is coming in slugs, so we need to use the slug catcher at the flux. Okay, and also it helps in separating the liquid from the gas. Let's check this small video about the slug catcher to understand how the separation occurs in the slug catcher. Okay. Here is the mixture of the liquid and gas is entering the slug catcher and moving like that. This is the first separation as a separator. The liquid goes down and the gas goes up through this pipeline. As you can see, there is still also some condensate here or some liquid with the gas. So it comes to another stage of separation at which the liquid condensate goes down by gravity. This is the benefit of the fingers, and the gases goes also above again and move to a separate pipeline like this. So this is the importance of the fingers. This is called fingers, and the separation is done by gravity. Liquid goes down and gas is goes up. This is the idea of slug catcher. As you know, as you can see here, the gas is above here, collecting and sending to the processing, and the liquid separated from the gas is sent to the other separation and condensate stabilizers. Okay. The next process is the sweetening unit or the acid gas removal unit. The acid gas removal unit is the main purpose is to remove the H2S, but sometimes CO2 is moved with the H2S based on the solvent selected or based on the process selected. The most common sweetening process is the amine sweetening process. The amine sweetening process at which it consists about the absorber and the regenerator. The absorber in which there is a contact between the gas and the amine suck or absorb the H2S from the gas and then sent to regeneration to separate the acid gas from the amine, and the amine is resent again to the cycle, and the H2S is going to SRU, and from above here the gas, sweet gas, is taken from the absorber to be sent for further processing and dehydration. Can anyone tell me why it's important to make the sweetening process before the dehydration process? Anyone know why we are when we make the sweetening process before the dehydration process? Anyone? No specific pipeline conclusion. We already have pipeline at which the product coming maybe a long distance as mentioned This is not the main purpose.
Because on the sweetening gas treatment, there is a mixture of sugar and honey. So I think it's not possible to do
Yeah,
the data.
yeah, then you are very very close because in the sweetening process, can you turn off the mic, please? Because in the sweetening process, we are using water. We already using water. The amine solution is not 100% amine. It's already consists of water, and there is also a mix of water. So we are putting water into the gas. So we cannot make the dehydration before the gas, remove the water before the sweetening, and then re-add water again. So the proper sorting or the operation must be sweetening after that dehydration, because there is water being inserted in the sweetening process. Okay, the dehydration process is mainly the same like the sweetening process, but with different solvent. Here we are using glycol. As the sweetening, we are using amine. But there is two different types of operations in the dehydration. Someone of them is the absorption. Absorption is done by glycol, and some other operation is the absorption, which is done by solid desiccant, such like the silica gel or a molecular sieve. The purpose of the dehydration process is to remove the water and dew point control. As we know, the dew point of the gas differs based on the amount of water exists on the gas. When the amount of water decrease, the dew point of the gas decrease, which is very important because the hydrate formation temperature is also based on the dew point and the water content of the gas. And when we reduce the dew point, we protect the gas from hydration, hydrate formation. We protect the gas from hydrate formation. This is the main purpose of the dehydration unit. Okay. This is the other type of dehydration unit, dehydration, which is by absorption by molecular sieves and or silica gel. Okay. After that, it comes to metering. Metering is in metering station is just a symbol or assembly of valves and flow meters, valves and flow meters in a certain way, and instrumentation only also. The importance of metering station is that you have to calculate or to know how much gas you produce or sell or receive from your company to the other company. That's why it's important to install the metering station in the gas plant. It's important in selling or purchasing the product. Okay, and there is also metering for as there is metering for gas, there is also metering for the stabilized condensate. Okay. After that, it comes to the SRU or sulfur recovery unit. The H2S out from the sweet unit is sent to sulfur recovery unit, which is the main or the most common process of sulfur recovery unit is the Claus unit, which is consists of a thermal reaction and afterward a catalytic reaction, at which the H2S is converted to a liquid sulfur, and after that we can convert it to solid sulfur. Okay, and it is important also for the environment. The SRU unit is very important for the environment, and at the current recently there is also some unit called a tail gas treatment unit, because the conversion inside the SRU is not 100%. There is a residual gas or tail gas. Recently, a lot of plants are installing a TGT unit or a tail gas treatment unit to increase the recovery of the sulfur from the H2S and minimize the emission. To minimize the emissions. Okay. As we mentioned, liquid coming from the slag culture or separation or the well consists of oil and water and sometimes MEG. When you are talking about MEG, the MEG is monoethylene glycol. Monoethylene glycol. Some plants are using monoethylene glycol, injected the MEG into the well to inhibit the hydrate formation. And after injecting the MEG into the well stream, it comes to the to the plant, to the processing plant for recovery, to recover MEG from the liquid. So here in the separation, we are separating the liquid into water and MEG together because water is mixed with MEG and oil. Oil is mainly the condensate which is sent to the stabilization. And also there will be some gases went out from our stream. It's sent to a compressor and after that sent to the sweetening again. Okay. From the separation, we take the condensate to the stabilization unit at which we can produce the stabilized condensate. Stabilized condensate, the main purpose of stabilization is to remove the H2S and remove the lighter components from the condensate. Okay, so we remove the acid gas, we adjust the RVP, which is the red vapor pressure. Okay, and we also have to meet the specs. The specs for the liquid is H2S is 10 ppm, and the RVP is up to 15 psi, depends on the either it's summer or winter. Summer should be a little lower, maybe 8, and in winter should be up to 15. This as the red vapor pressure increase, as the lighter components increase, and this allow in the winter especially allow the engine to start more easily. This stabilization process is just like the fractionation or the distillation. It's a heating process and then separation based on the boiling point. Okay, this is a very simple BFT of the stabilization process. After that, or the last process in the which medium is used in the exchanger. There is a lot of mediums we can use in the exchanger. Here we can, if there is no product, we can use the product already instead of using a cooler. Here we can use the product to be exchanged with the inlet stream, or you can use steam. For example, at our plant in Zoft Gas Field, we are using steam. Some other plants are using hot oil instead of the steam. So there is a lot of variants you can use. We can use in the exchange. Okay. So, but the most economical option is to use the product, the hot product to be exchanged with the feed. Okay, this will reduce the heating duty and reduce utilities such as like steam or hot oil. Last operation in our plant will be the SWS, sour water stripping. Sour water stripping is more or less like stabilization, but at which we are removing H2S and lighter component from the water, from the sour water, and then we can reuse it or send it to disposal. Okay, SWS is more or less very like the stabilization process. It's very similar to the stabilization process. Okay, last operation is the MRU, which is MEG recovery unit. As we mentioned, monoethylene glycol is being injected to the wells for hydrate inhibition, and after that we recover the MEG because it's very expensive. So we recover the MEG to be re-injected again in the system. And this process consists also of heating and fractionation. But there is most important, the most important is this process must be done under vacuum. Must be done under vacuum. Can anyone tell me why this process must be done under vacuum? This is last question. Can anyone answer why this process must be done under vacuum? Okay, I will answer. As we know, when we reduce the pressure, what will happen to the boiling point of the component when we reduce the pressure?
It also reduce.
Yeah, the boiling point reduce. So when we are fractionating the MEG, we are using vacuum to reduce the boiling point of the MEG. Why we are doing this? Because the degradation temperature of the MRE of the MEG is very close to the boiling point. The degradation temperature means the MEG will reach a point at which it will not be, it cannot be reused, it will be degraded, will not be valuable anymore, cannot be recovered. So the degradation temperature is around for the monoethylene glycol 165, and the boiling point is around 135. That's why we are using vacuum to reduce the boiling point up to 110. To cover all the operation upsets. Some operator may forget the steam flow for some time, which will increase temperature and reach the degradation temperature, and we will lose all the MEG, which is very costly and very valuable component in the plant. That's why we have to make this process under vacuum. Okay, and also there is some salt recovery process done in the MRU because the fluid coming from the pipelines must have some salts and some vessels, sands or solid items. And also because sometimes when the water comes from the reservoir, it becomes very salty, and we have to remove this salt from the MEG to be re-injected again to the wells. This was an overview about the process. I hope I could increase your knowledge and tell you something new, and I hope it will be very valuable to you and beneficial for you. If anyone have any question, please say it to me, and I hope I can help you.
Our society produces a lot of waste, over 2 billion tons per year, in fact, a number that's expected to grow by 70% by 2050.
That's a line of garbage trucks stretching from San Francisco to New York City every single day.
Organic materials in landfills decompose, they produce methane, a very potent greenhouse gas.
Solid waste.
Rồi, hôm nay chúng ta xem sơ một số video như vậy để chúng ta có nhìn sơ bộ về cái khái niệm của môn học cũng như là những cái mà chúng ta có thể tiếp cận trong cái môn học này. Đặc biệt là những cái mảng liên quan tới điều khiển quá trình trong các hệ thống như hóa dầu hay là thực phẩm hay là các cái mỹ phẩm vân vân. Thì ở đây nó không có quan trọng lắm tới gọi là cái phần gọi là tốc độ, nghĩa là cái đáp ứng quá độ, nhưng mà cái phần quan trọng nhất là liên quan tới gọi là làm sao để set up về hệ thống, rồi thứ hai là an toàn và một số các yếu tố liên quan về điều khiển các hệ thống mà cái tính trễ của nó cao, để làm sao mà chúng ta có thể là nâng cao một số gọi là chất lượng của một số hệ thống. Đồng thời thì trong môn học này thì chúng ta sẽ nắm một số các cái gọi là đặc điểm cơ bản trong cái hệ thống gọi là BNAD. BNAD là cái sơ đồ đấu nối thiết bị và các cái đường ống, thiết bị và đường ống trong một cái hệ thống như thế nào ha. Thì lúc nãy là chúng ta vừa xem xong một cái giải thích liên quan tới một cái quy trình về hóa dầu thì ở đó thì chúng ta chưa có nắm sâu, tuy nhiên là hy vọng là chúng ta sẽ gọi là xem kỹ cái video đó và chúng ta sẽ nắm thêm kỹ các thông tin chi tiết. Còn cái video thứ hai chính là cái outcome của môn học của mình, nghĩa là những cái thông tin mà chúng ta cần nắm được trong môn học này Thì môn học này thì yêu cầu chúng ta không có quá nhiều. Thứ nhất là chúng ta sẽ nắm bắt được một cái hệ thống, và với kiến thức của một cái người điều khiển thì chúng ta sẽ hình dung được rằng là một cái quy trình công nghệ hay là một hệ thống thì chúng ta involve vào trong những cái chức năng gì. Thứ hai là chúng ta nắm bắt được các cái trang thiết bị trong hệ thống đó, từ đó chúng ta sẽ xây dựng các cái bài toán lập trình. Thứ hai là chúng ta sẽ tập trung vào cái bài toán là các cái đặc tính trong các cái process, nghĩa là và trong đó thì hai đặc tính chính đó là thời gian trễ, thứ hai là liên quan tới đáp ứng ngược. Đáp ứng ngược nó cũng gây ra cái gọi là cái độ trễ của hệ thống. Từ đó chúng ta đưa ra những cái giải pháp khắc phục về một số thuật toán liên quan tới khắc phục cho cái thời gian trễ. Đồng thời là chúng ta tìm hiểu thêm một số các cái giải pháp hay là các biến thể của bài toán điều khiển BAD trong hệ thống công nghiệp thì trong đó nó có rất nhiều cái biến thể về BAD và chúng ta có thể tham khảo. Và cuối cùng là chúng ta sẽ thực thi các cái bài toán điều khiển trong cái đối tượng thực, và ở đó thì chúng ta ứng dụng các cái bài toán điều khiển đó vào PLC. Chúng ta xây dựng một số các cái giải pháp điều khiển trên PLC, và cuối cùng là chúng ta sẽ làm thực nghiệm một số bài toán liên quan tới điều khiển mức và điều khiển nhiệt độ, bằng các cái giải pháp điều khiển mà chúng ta nắm bắt được trong cái suốt quá trình học. Đấy là một số các cái vấn đề của môn học của mình. Thì chúng ta về xem kỹ các cái nội dung video, và sau đó thì các bạn nốt lại những các cái chính. Thứ nhất là nốt lại các cái chính của các video đó. Thứ hai là những cái thắc mắc, những cái câu hỏi liên quan về các video. Rồi thì hôm nay chúng ta dừng ở đây, gặp lại hôm sau.
Chào thầy.
Sao Lộc, có gì cái ý kiến gì theo không?
Dạ có tuần sau mình cũng học như vậy hết.
Ok thì chắc tuần sau chị ơi cũng học online đi hả? Khi nào offline thì sẽ báo. Rồi chúng ta nghỉ nha các em. Rồi hẹn gặp lại hôm sau. Bye bye con.
Bây giờ
Ừ.
Chào thầy.